We're doing Euclidean Geometry on a subtopic known as a circle geometry. Circle geometry. This is part 2. So in this part of the video, we only will be focusing our energy on tangent. Now, what is a tangent? Tangent on circle geometry is you have a circle, and then you must have a line passing through a circle. It has to touch the circle once, right? It's a line touching the circle once. It has to touch the circle at once. So this is your tangent. Tangent, it's a line that touches the circle once. When you talk about the tangent in circle geometry, right? Now, what are the theorems that you can have about tangent and circle? Let me give you one. Let me draw a circle. And yeah, let's say you have now a tangent. Let's say you have a tangent like this. And you have a line from a center of circumference. And from our previous videos, we discovered this line here from the center to the circumference is your radius. So you have a radius and you have a tangent. Cool. So you are given, if given, let's call this A, call this B, let's call it C, let's call it O. If given OB is a radius and AC is a tangent at point B. So the tangent and it touches at point B, right? Then your result will say that the line, the tangent, the radius. Remember, this is your radius. This is your tangent. The radius is perpendicular to the tangent. That's what it means. So that's your result. Your result is you have a radius. So you have your radius. You have a tangent. So if you have a radius and tangent and the emitter is point B, then your radius is perpendicular to your tangent. And your reason is simple. Your radius, which is OB, is perpendicular to the tangent, which is AC. That's your reason. So basically it's one theorem. So let me give an example on this. Maybe you might catch it. Let me give an example. Let's say, example. Okay, you might, probably the question will be, say, find x, right? Find x, you're given a cycle, which is cool. You're given a radius, which is great. And you're given, let's say it meets once there. I know it doesn't look like it meets at one point, but let's try again. That's better. And meets at that point. That's a tangent. Let's call it A, let's call it C, let's call it B that side, right? And then probably the question was saying find x, and find x where x is equal to, let's say maybe we call it C1, C2. These are angles. Is equal to angle C1. What is your x, right? So what you're gonna say is, you're gonna say, okay, cool. My x, cool. Angle C1. Okay, let me just write this way. Is x is equal to angle C1, and angle C1 is 90 degrees. Remember, this means if it's something is perpendicular, it means 90 degrees, right? So x is equal to C1, and C1 is 90 degrees. It's 90 degrees. And the reason for that is because OC which is a tangent, is perpendicular to AB, which is your, OC, which is a radius, is perpendicular to AB, which is your tangent. That's your reason. Simple as that. Let me give you another